Hello guys, very good morning. Welcome back and let's start. So in the last session, we discussed about the Docker and Kubernetes syllabus. Okay, just we have gone through the curriculum and then we just saw the what is an on-premises environment and we need to discuss about the containerization. But before we go into the containerization, first of all, you need to understand why we have to understand the containerization or else why we need to go into the Docker. So Docker will carry the containers. Okay, so if you can see here, Docker is not a separate software and container is not a separate software. Docker and container both are into a single software. Okay, so if you can see Docker ship. Okay, in general, you will have a ship like this. Okay, so this ship will carry the containers. What will be there inside the container? Inside the containers, you are going to have the multiple goods. Okay, either it might be any good, any good, it will be there inside this container. So who is going to carry all these containers? A Docker will be carrying this. So whatever the blue color ship you are seeing, this is called as Docker. On the top of this, you are going to have the containers. So each container will have a different kind of goods will be there. Some containers will have coal, some containers will have the textiles, some containers will have what I can say, iron ore. Some containers will have something extra. So like that, each and every container will have its own goods. So now what is happening here? Whenever you are providing any container, so in general, if you come back to the IT world, in the IT, you will be having a Docker, and on the top of this Docker, you will have all the containers running. So these containers are very important. Even though Docker is an application that will hold the containers. So that's why if you can see, whenever we go for a Docker icon, okay, whenever you see the Docker icon, that Docker icon will be like a ship which is carrying the containers. Get there. So there is a ship that is carrying the containers, or else there is a very big whale that is carrying the containers. Okay, so in the same manner, so however that is happening in the backend. So what Docker is going to do, Docker will carry the containers. Okay. So now before Docker came, so you are saying Docker is carrying the containers. A container is a lightweight process that will hold the application and its dependencies. So just for example, try to understand the point here. We are going for an olden days. We will go back to the olden days. In the olden days, the olden days in the sense, for example, 1980s, 1990s time. Okay, we don't have these container technology. We don't have this internet technology very much highly available. So now, at that particular point of time, what we used to do, we used to run a server. We used to run a server. So when we used to run a server, that server, okay, when we used to run a server, and in that server, we are going to install the application. For example, now why we have to run the application? For example, there is a non-technical organization. Is there non-technical organization in the sense they're like hospitals or else your e-commerce websites and as well as your banks. These are all comes under non-technical. So when they, I mean, non-IT sector companies. When a bank comes to the IT service industry, so like your Infosys or also TCS or Wipro or any another IT service company. Okay, so it will approach the IT service company. So what are the requirements for the bank? So the bank requirements are, in general, in the good olden days, they used to maintain a ledger. Okay, they used to maintain a ledger. In that ledger book, they are going to write each and every account details, which is a very hectic task. Now, to overcome this point, what they have done, they went near to when this IT world is evolving. At that particular time, they went to an industry. Either it might be one of the company, any one of the company. They went to one of the IT service company, and they have asked, I want a limited features. Okay, for my accounts and all the things, I want a limited feature application. Okay, so this particular company has developed it and gave back to the bank. Now, after some years, what is happening? So they want more comfort. The customers want more comfort. So what they have done is they went back to the same IT service company and they asked that we are planning for an ATM mission. Okay, we are planning for an ATM mission where the user can withdraw the money at any point of time. Okay, so they have developed an application and gave back to the bank. Okay, so next one is after a few days, they went back to the same IT service company saying that we want more comfort for our customers. So I don't want my customer to come to the bank. Okay, I don't want the customer to come to the bank. I want the transactions to be happening, but the transaction should happen through only internet banking. So they asked the IT service company to develop a solution with the internet banking. So this IT service company, what they have done inside their organization or else inside their company, there will be multiple teams will be there. What are those teams? What are those teams? The teams are development team. Okay, in the development team, you will have all the developers. Okay, you are going to have all the developers. And what developers are going to do? Developers will develop a code and commit the code into the Git and or else any version control. And in the olden days, if you're not having anything, they are collaborating with each other in a different manner. So now they are having the code with them. Okay, so the developers are having the code with them. Now, once the code is developed, now, where they are going to deploy that to test whether the code is working fine or not in their internal organization, or else on their on-premises environment, they used to have a they used to have some servers. Okay. So what are these servers? These servers are nothing but the development servers. Okay, whatever the servers that you are having, these are the development servers. So what they are going to do, they are going to deploy the code onto the servers. They are going to deploy the code onto the servers. Okay, so now once the code is deployed on the server, now what is going to happen? They will generate an URL, a temporary local URL, and give it back to an another team. What is the another team here? They are called as testing team. Okay, internal testing team will be there, and this internal testing team, they are going to do the testing of that particular application. Okay, they are going to do the testing of this application. So when they do the testing, if they find out any bugs on that particular application, they are going to report it back to the development team, and this development team is going to again fix that particular issues and re-release the application, and that application will be into this development servers. Okay, so these development servers are maintained by another what I can say, another team. Okay, that team is called a system administration team or else server administrator team. So there is another team who is going to manage your servers. Okay, I will call it as operations team, ops team. Okay, ops team or also operation team who is going to manage and monitor your servers. If there is any downtime for the server, everything will be managed by the operations team. So now everything is fine over here. Now this particular application, now the testing is successfully happened. Now I want to migrate this entire application from the development environment to the UAT environment. Okay, I want to move this entire application from development to UAT. UAT in the sense user acceptance testing. So this is the bank, and in the bank also you will have the environments created. Actually, so we can show the application from our servers to the client itself. So by installing our application in our development servers, we can make them understand our application. But if the user is accepted, okay, if the user is saying that okay, we understand whatever the application that you have developed and we are very much satisfied with the application, you can release it to production environment. So this production servers will not be with the IT service company until unless if the bank is requesting to have that posting also in the IT service company. Okay, until unless the bank is saying that okay, we want the application to be installed on your servers only. We don't have the servers. We don't have the servers. For that, we will pay you. So they are going to say we are going to pay you for the IT services, whichever you are providing, like servers and all the things, we don't have a proper money. So we request you to create the servers, the production servers, and then you have to deploy the code. So then IT service company is going to create the server and going to deploy the code on their environment. So this is one of the option that you are having. Now, if not, what is going to happen? This bank team, I don't want my code to be deployed in some another location. So I want my code to be there in my servers only. So then we will guide them. IT service company will say that these are the requirements, these are the server requirements. You have to get that done inside your bank, and these are the application prerequisites. So if an application has to run, for example, there is a Java application. This Java application has to run, and it has the software dependencies like Spring Boot, and as well as Java 17 version should be installed, and the database should be MySQL or PostgreSQL or Oracle, and uh, so they are going to say each and every dependencies. Tomcat should be installed, and for proxy, Nginx server should be there. So these are all the requirements that we are going to give for the bank. So the bank has to create all the services, all the servers, and has to install everything, and as well as it has to install the security, SSL certificates, and everything has to be done from the bank end. Now, this application code once developed from the IT service company, and they are very good, okay with the code. And now the code will be into the production environment where we are going to deploy. IT service company engineers are going to deploy that code in the bank server. So when the code is deployed on the bank server, so now here you can see the migration is happening from the development environment to the production environment. Now this code will be available in the bank server. So now what should be done here? So the bank has to replicate exact the same environment which is there in the development environment. So to replicate that, it is going to take so much amount of time. Why? Because they are not professionals, even though if they are having pretty much high knowledge, but still they have to install all the application, they have to configure everything. So which is a tedious task. Okay, so they have to install Java, they have to install Spring Boot, they have to run the Maven, they have to install NFS, they have to install SSL certificates. So there are a lot of things that should be taken care by the taken care in the production environment. But you come to development and UAT, you don't need these certificates and all the things. Why? Because we are under the development, so it is not a requested or recommended. Certificates are not required here. But what is happening whenever you develop the code, so and it is into the production environment, definitely you have to go for the NFS setup and the certificates, and then application related configuration, database configuration. These are all the things that should be done. So to do this, definitely it is going to take lots and lots of time and efforts. Now, I don't want this can be happen. So what I want to do here is within a short span of time, I want to make my application generated in the development environment, or else it has to be migrated from development to production environment within very short time and with all its dependencies. So what I can do, so when you see here, this is a heavy weighted application in the sense it requires more amount of CPU and RAM, it requires more number of softwares, it is having more number of dependencies. So now what I have to do? So to overcome this problem, whatever the problem that we are having, we are going to convert this particular application into a small image. And that image is called as a Docker image. Whatever the application code that you are having, this application code and its dependencies, we are going to convert into the form of an image. And that image is called as Docker image. And this Docker image is very lightweighted. So if you see any Docker image, it is not going to be exceeded more than 1 GB. Okay, it is not a recommended practice to have an image with a higher size, like 9 GB, 10 GB. It is not a recommended practice, but most of the images will be varying from 1 GB. The maximum will be 1 GB of storage. Now that particular application will be forwarded to the client. So the client will create that image and convert that image into a container, and they will run the application. So in general, this is what the process happening in the backend. So whatever the manual process that we are doing over here, migrating the code from one environment to the another environment and installing all the softwares and its dependencies. We are going to eliminate the everything in a possible way by using a Docker. So that's the reason why we need the Docker and containerization platform. So now let us see what is meant by a container and what we have to work with the containers. Do you understand the process here? Any questions? Guys, any questions? Do you understand the process? Is there anyone?
Yes, sir,
Hello?
got it. Yes, sir, got it.
Okay. So everyone, I'm asking about everyone. So there are any questions related to this? Why? Because we will be going into the most important concept of understanding the containers or else. So before we go into the containers, you need to understand the virtualization platform, and later we will be going into the containers. Okay. So now let us discuss about an virtualization platform. So what is this virtualization platform? Why we are going with this? So virtualization means creating logical servers in a single physical server. Sir, I didn't get it. See, whenever you are having a physical server which with heavy resources, you are having a physical server with heavy resources. So like 32 CPU and 1 TB size of RAM. So in general, you will be what I can say, you will be surprised to hear 1 TB size of RAM. That is very normal in the server. Okay, so 32 CPU, 1 TB of RAM, or else let us go with 512 GB of RAM. Okay, there is a server with 32 CPU and 512 GB of RAM, and this is only the hardware that we have purchased, the server which we have purchased. Now what I will do here is I can install the application, or else I can install the operating system and run the application. But what I want to do here is I want to divide this server into multiple logical units. Okay, simple. You purchased a hard disk. The hard disk size is some 4 TB of hard disk you have purchased. Now, when you purchase the 4 TB of hard disk, are you going to do any partitions, or else you can use directly the hard disk? In general, it's both the way. You can use the hard disk, or else you can do the partition. But when you do the partition, what is going to happen? This partition is for my personal storage. This partition is for my office storage. This partition is for my entertainment. So these are all the different kind of partitions that you are going to do. So whether you are going to break the hard disk, or else you are going to logically divide the hard disk, how you are going to do this? Uh, yes. So, do you understand what I'm asking? You are having a hard disk and you are going to divide the hard disk into multiple, what I can say, you are going to divide that hard disk into multiple partitions. So, whenever you are doing the partition, are you going to break the hard disk and make that this is the 512 GB which I want to make it for my office file, the 512 GB my personal work, 512 GB for my entertainment, 512 GB for any another purpose. Are you going to break the hard disk, or else logically divide the hard disk with the help of a software? How you are going to do that?
Logically dividing the part.
Yeah, you are going to logically divide the hard disk with the help of a software. In the same manner, here also, whenever you are having a server, this server will be equipped with a huge amount of resources. And now you are not going to divide the server into multiple. I mean, you are not going to break the server. You are going to logically divide the server into multiple logical virtual machines by using a software called as, on this directly on the hardware itself, you can directly install a virtualization software, and that virtualization software is called as, either it might be virtual machine, I mean VMware, or else it might be Citrix, or else it might be Windows hypervisor, like that. There are so many what I can say logical softwares that are available in the market. So I'm going to use VMware ESXi, or else you can use Citrix, or else you can use Hypervisor, Windows for V. Okay, so I'm giving only a few softwares, but if you go to the market, there are so many different another softwares are available. Any of the software you can install. So on the top of this virtualization software, okay, so now there is a connection between the hardware and to your virtualization software, and this is the server software. Now the client is going to connect to the server software through a vSphere client. Okay, there will be a desktop. On the desktop, he is going to install an application called as vSphere. If I am talking about the VMware, there is an application, client application called as vSphere, so that what uh, what this VMware is going to do, VMware will understand or analyze the server hardware. So this much amount of resources are available, and that will be given to the vSphere client. Now user will be able to access the vSphere client, and user will understand, okay, this server is having 32 CPU and 512 GB of RAM. So now what is my requirement? With the help of this vSphere, he is going to create a server. On the top of this virtual machine, he is going to, the user is going to generate a virtual machine. Okay, so this is my virtual machine which I am going to create called as VM1. Okay, so this is my VM1. Now, this virtual machine is of size somewhere 2 CPU, 4 GB of RAM. 2 CPU, 4 GB RAM. So from where this hardware will be collected? So the hardware is going to be collected from the physical hardware. Whatever the virtual hardware that you are seeing here, this will be collected from the physical hardware with the help of this existing software called as VMware. Now, on the top of this virtual machine, we are going to install an operating system. Okay, we are going to install an operating system, and this operating system is either it might be it's a guest operating system, guest OS. Okay, either it might be Linux or else it might be Windows, any operating system we are going to install. For example, we are going to install Ubuntu. Okay, Ubuntu operating system we are going to install. So one thing you need to understand here is whenever you are installing an operating system, I'm saying that installing the operating system, we are not directly using the binaries and libraries. We are installing in the sense, so the hardware should understand, okay, so there is something called as kernel is getting created, and that kernel involves in communicating between your operating system and the hardware. So now when you install the operating system, kernel will be there. If you don't install the operating system, but you use only the environment like binaries and libraries of that operating system, then kernel won't be there. So now we are installing the operating system, which means that a kernel will be there. So what is the main use case of kernel? Kernel is like the heart of your operating system. Without the kernel, if you create any application or else if you create any operating system, that won't be able to work. So now what is going to happen here? Whenever you install the operating system, a kernel is created. So this kernel will be acting like an interaction between the OS and the hardware. So OS will be in the higher language level. Okay, either it might be written in C, C++, or else any higher language. And hardware will be in the lower language in the sense hardware can only understand the binaries. Okay, binaries, binary numbers, ones and zeros. It cannot understand the high level language. So whenever the user requested to open any application, so if kernel is not there, directly OS cannot communicate this thing to the hardware. So now in between that, you will be having a kernel. So this kernel is like a compiler. So what is meant by a compiler? A compiler is a resource which is going to convert the source code into binary format. Okay, machine understandable language. So that can be done by your kernel. Not only that, it is going to do the memory management, storage management, process management, network management, everything can be done by your kernel. So now when we install the operating system, keep in mind that we are going to have an heavy weighted applications. Okay, heavy weighted applications in the sense on the top of the operating system, we are going to install the application dependencies first. To run any Java application, you have to first install the Java, and then you have to install Spring Boot, and to create an artifact. which means that if I want to convert that code into a jar file, that jar file is nothing but an artifact. So to generate that, you need to have another dependency called as maven or gradle. So these type of dependencies should be installed. So on the top of your operating system, what you are going to do, you are going to install all the dependencies. Okay, these dependencies will be installed. Once the dependencies are installed and everything is fine, on the top of this, what I can do here is I can install my application. I'm going to install my application. So which application? I'm going to run that application java-jar and that jar file. So the application will be running on the top of this. So this many things that will be happening whenever you want to run an application. Okay, now the application is running fine and I don't have any problem with the application. For example, this virtual machine is in your development environment. This virtual machine is in your development environment. Now, if you want to replicate the same in the production environment, again, you have to create a virtual machine and that is not necessary. Simply what you can do here is you can migrate this particular virtual machine. There are certain tools. So this you can migrate this virtual machine into the testing environment and as well as the production environment. But this migration will be very tough. Okay, so the point is it's a heavy weighted application because it has to migrate the entire operating system and its dependencies and all the utilities and as well as the application. If you can see, you have to pack the operating system and you have to pack the dependencies, you have to pack the application. So in the operating system, there will be so many utilities are available which are unnecessary for the application. For example, there is NS lookup will be there. It's a utility which is not recommended or else which is not needed every time. So unneeded or else not needed dependencies will be more or else utilities will be more when you are installing an operating system. So to eliminate this kind of heavy weighted applications, we are going with another concept called as software virtualization. Now, whatever you are seeing here, this is called as hardware virtualization. Now we are going with the software virtualization. What is the software virtualization? Nothing but containerization, or else we are going to use the containerized applications like Docker, ContainerD, RKT, CRIO. Like that, there are so many containerized applications. So we will be mostly hearing about the Docker. Docker is not the one containerization platform. There are so many another containerization platforms like Docker, RKT, ContainerD, CRIO, Podman. Podman is one of the containerization application in the Red Hat Linux. So like that, you will be having so many different type of applications are available. So among that, the predominant or else the most significant role will be played by your Docker. So that's the reason you will be hearing mostly about the Docker and its configuration. But you need to keep in mind one thing, that Docker is not only a single containerization platform. You will be having so many different types of containerization platforms. Among them, Docker is one of the platform. Okay. So do you understand the point here? Any questions up to now? Am I going a little fast or else what's your response on this? Any questions? Okay. So now we are going with the software virtualization. What is the software virtualization? In the software virtualization also, we will be having the physical hardware. Okay, we will be having the physical hardware where you are going to have the same configuration. Again, there is no necessity for writing all this. So let me do the same configuration. But what we are going to do here is on the top of this, we are going to install the operating system. So this is called as host operating system. The main operating system which is directly installed on your hardware is called as host operating system. Previously, we have installed the operating system on the VM. So that's called as guest operating system. If we are directly installing the operating system on the hardware itself, it is called as host operating system. It might be Linux or else it might be Windows. Okay, it's your choice whether you have to go with Linux or Windows or Macintosh. That's totally your choice. On the top of this, what I'm going to do here is I am going to create a Docker engine. I'm going to install the Docker engine, Docker or containerd, any containerization. But we are learning about the Docker, so I'm going to install the Docker engine. So this Docker engine will be an application. So what is this application? This application is nothing but like your Google Chrome. So for example, if I am open, not only Google Chrome, if you can see Edge browser is an application, but when you open the Edge browser, you have to use certain URLs. So depending on the URL, it is going to open an application, web application for you. So now when I go for Docker, it is showing me the Docker URL and I mean a Docker application. This is a separate process. Whatever the new tab that you are seeing here, this is a separate process. Okay. And this new tab is having another application. This is another web application which is having the Amazon. And this is the search engine where you are seeing the Docker images. And this is my Gmail application. So now what is happening? Three different tabs are having three different applications. One tab is having Gmail application and one tab is having Amazon application and one tab is having Docker application. And another you are having a new tab where it doesn't have any sort of application running. So, I mean, what is going to happen here? So these tabs will consume the resources. These tabs will consume the resources. If you see here, let me show you one thing. If I open the Edge browser, so where is the Edge resource consumption? Look at that. This is the browser consumption. So what is the browser consumption? It is consuming 870 MB. Whatever the three tabs that I have opened, it is consuming 870 MB. If I close the Gmail tab, if I close the Gmail tab, the resource consumption should be reduced. Previously, it is 870 MB. After closing the Gmail tab, it has become 840 MB. If I close the what I can say this image tab, okay, Docker image tab. Now what is going to happen? The resource consumption should be reduced. Okay, so now what I will do, I will close this new tab also. When you close the new tab also, it will be reduced to something down. So see that it is reduced to 730. So it is getting reduced to 700, 568. So why? Because there are no processes are running in the background. When there are no process running on the background, obviously the resource consumption will be very less. So in the same manner, we are going to install the Docker. On the top of the Docker, we will be running certain processes called as containers. Containers are nothing but a process. Okay, process, an application process, just like your tabs which we have opened. These tabs are also called as processes only. What will be there in the tabs? In the tabs, you will have an application running. Here it is called as a web application, and there in the container you are going to run the normal applications. Okay, so this web application will be pulled from the server and shown in front of you. Okay, so nothing much difference. But the point what you need to understand here is, so the Edge browser is also a software, and as well as Docker is also a software. It is nothing more special in that. Okay, so both are the equivalent things. So Docker is also a software. So now if I open the Docker, now see here, what is the resource consumption right now? What is the resource consumption right now? If you can see, it is 59% of memory is consumed. If I open Docker desktop, now what is the resource consumption? The resource consumption will be a little bit increased. So let me show you that. Okay, see that the Docker desktop is now consuming. So why it is consuming? Because inside the Docker desktop you are having, it is starting and you are having certain containers. If you are having certain containers, these containers, when you start the container, right now what is the consumption? The resource consumption is only 300 MB. So let me start a container, test container. I am going to start it. When I start the container, it is going to, the resource consumption will be a little bit increasing. So which means that whatever the containers that you are seeing inside this Docker application, these are also called as processes. So when I start the another application, when I start the third application, so all the containers are running. So when the containers are running, obviously the resource consumption should be increased. Okay, so it is going to increase. Now the point is what you need to understand, these containers are like the processes, and these processes will be holding the application and its dependencies. So we are going to create a container on the top of the Docker. Okay. So this container, whatever we are creating on the top of the Docker, this container won't have any type of operating system installed. Try to understand the point. On the containers, we don't have any operating system installed. Operating system will be there, but it is not going to be installed. We are going to use that operating system environment binaries and libraries. We are going to use the binaries and libraries. Apart from that, we are not going to install the operating system, or else we are not going to install all the utilities. Whatever the required utilities are there, we are going to use only them. So when we install the container, on the top of that, I am going to run the required operating system binaries and libraries. Okay, so all the binaries and libraries will be there. Unnecessary software will be removed. Ubuntu operating system environment I am taking. I am not installing it. I am just taking the binaries and libraries. So the bin folder and library folder. So it is going to create your image. On the top of this image, I will install the, what I can say, I'm going to install the Java related dependency. Okay, so no, sir, I don't want this. So there are certain images which you are having a Java installed. So I am going to use this Java image. Java image is also available. For example, let me create a container so that you will clearly understand here. So Docker ps, we have 3 containers running. Let me create a container with Java installed. So we can directly create the container with the Java installed application. How I can do that? Docker run -itd -name. What is this -itd? What is happening? Each and every option I will tell you. Don't worry about this. Just I am showing you a small demo. -name, Java container, and images. There is OpenJDK 17, Docker image, OpenJDK 17 Alpine. For example, if I take this, okay, let me take this. So the image size is very, very less. So somewhere around you will get some 400 MB of image will be there. I will show you that. So hold on. OpenJDK 17 Alpine. I'll take this. Okay. So I'm going to install the Docker container here. I'm going to create it. So now what is the size of this OpenJDK 17 image? Let us see that. So the container is getting created. On the top of Docker, we are creating the container. Now here also you can see. So what is the container name? Java container is created. So when it is created 6 seconds ago, 6 seconds back, we have created. And what is the status? The status is running. Okay. This is fine. If you see the green symbol, the green symbol means the container is running. Okay, fine. So now Docker images. Here you can see the OpenJDK images of size just 326 MB. But if you create a Ubuntu image, on the top of that, if you install the Java image and everything, it is going to go with 700 MB. But we are directly using the Java related image. Okay, so now let me log on to that container. Docker execute -it. I am going inside the container. Docker execute -it. Java container -sh. Simply if I give sh, so I will be inside the container. Java version. If I try to do this, look at that. I'm having Java 17 version installed on my container. Okay, simply I can do this. So what is the size of the image here? 326 MB. What will be there inside the image? You will have nothing except the basic requirements to run an application. Whatever the basic applications you want, that will be there inside that image. Apart from that, you don't have anything else. So that is the reason you are having only 326 MB. Why? Because you have Java also installed. So that's the reason 326 MB of size is available. Now, if you can see the Ubuntu image size, that is only of 78 MB. Okay, so this much amount of less sizes of images are available because we don't need to install the operating system in the container. We just use the image and we can create the applications. Now, as you can see, we have installed the, what I can say, binaries and libraries. Now the container is running. So this container will hold the application, and the application size, if you see, you will be installing the application and this application will be running. But the most important point, what is missing here is to run an application. So what is very important, the process management, memory management is very important. So now how container will be started, how container will start and how application is going to get the resources. So actually container is not going to install any operating system. If it doesn't install a operating system, the container will not have any kernel. Now how container will manage that application? To manage this application, this Docker will communicate with your host operating system, and host operating system will communicate with the kernel. So what is the point here? The container is directly going to access whatever the containers that are creating. The containers are directly going to access the host operating system kernel. They are going to access the host operating system kernel. So that's why there is no necessity of kernel. Kernel is eliminated, operating system installation is eliminated. So we are going to use only the binaries and libraries of the operating system. And then we are going to install our application, which is a very lightweighted application. And now if you want to convert this particular Docker image, for example, there is a Docker image here. So now if you want to convert the image and you want to move that image to the production environment, what you can do, simply come out of the container. So Docker PS, here you are having the a container called as Java container. So now I want to convert that into an image format, Docker images. How many images are there? There are 3 images. One is the OpenJDK image and the Ubuntu image and Nginx image. These are the 3 images. Now, if I want to convert this container into an image format, what I can do, for example, assume that inside the container, we are having all our applications running. So now I want to pack that container and I want to move the container from one environment to the another environment. How I can do that? Simply docker commit, or else first of all, let me, docker commit Java container to Java version 1 image. So I'm just committing it. So now if you see Docker images, here you will be having Java version 1 image is available. So which is of size 326 MB. Now what I want to do, I want to push this image into my Docker hub. So let me Docker login -u Chaitanya Manikumar. Okay, so I'm logging into my Docker account. So once I logged into my Docker account, now what I can do, Docker tag whatever Java version 1 is there. I want to tag it to Chaitanya Manikumar / Java version 1. And I will push into my public repository. So let me show you that Docker push Chaitanya Manikumar Java version 1. Whatever the Java version 1 you are having, I am going to push it into my Docker hub. Okay, let me show you. So I will go to my Docker hub. So you will get a clarity. But what I am trying to say you here is how fastly we are able to move those images from one environment to the another environment. So here you can see I got my Java image. Chaitanya Manikumar Java version 1 is available right now. This is the repository. So now what I will do, I will go to my AWS account. I'm going into my AWS account. And in the AWS account, I am having a Docker server. Okay, let me show you that. So think this like whatever the Docker that I am running in my in my laptop, this is like a development environment. Just think like this. This is the development environment where I am running my Java related applications or else any development related applications. Now think that this particular server, whatever you are seeing in the AWS environment, it is like my production environment. Just think that. So this is my production environment. Simply what I have to do here is, let me access that server. So hold on. Okay. I'm going to access the server over here. You will have so many questions. I will try to answer all the questions. Don't worry about that. Ubuntu. Sudo su hyphen. So Docker PS, we don't have any containers running right now. Let me start the container. Docker run hyphen itd hyphen name of the container is Java prod container with the image Chaitanya Manikumar / Java version 1. Okay. So now automatically within seconds, what is happening, whatever the application that is running, whatever the image that is available in the development environment, I'm going to create in my production. I'm going to replicate the same in my production environment. Here you can see the Java production container is started and it is running. So this much easy how you can migrate or move your application from one environment to the another environment because of the very lightweighted application images. So this is about your Docker and its containers use cases. So later we will discuss about what is this container and why we are running the containers, what is the necessity of the, on what basis the containers are created and what is a Docker image. Just now you have seen the Docker image creation. So what is this Docker image? Is there any another way to create the Docker image? These are all you are going to learn in the next upcoming sessions. So as of now, that's it from my end for today. If you have any further questions, you can ask me now. Do you understand the concept? Any doubts here? Questions, please. Everyone. Yeah, Bala. You have any doubt or else do you understand the concept? You said yes, I didn't get it. Okay, fine. Guys, questions, guys, please.
The class time every day will 7:30 or it will move to 6:30, sir?
Okay, attend the yesterday session. I said yesterday itself clearly, it's from 6:30. From Monday, it will be 6:30.
Okay.
Tomorrow,
Actually,
tomorrow
today is
also
my
you will
last class.
no. Tomorrow also you will have a session.
Okay, sir.
Okay, tomorrow also you will have a session at 7:30. Tomorrow also 7:30 a.m. only. But from Monday onwards, you will have the session at 6:30.
From Monday, like 6:30 to
8 o'clock.
8, is it? Yeah, today is like my first
Yeah,
day.
see, okay, no problem. 7:30 to 8:30 or else 8:15, that will be on demos. But once we moved into the main sessions will be started at 6:30 a.m. and it will be continued till 8:30, sorry, 8 o'clock, not 8:30.
Okay. And the batch, is it like from Monday to
Every day you will
Saturday
have
or
the session. Every day you will have a session. Most probably it is a 25 working day sessions. Okay, the entire Docker and Kubernetes will take some 25 days of time. So among the 25 days, most probably I won't give any leaves. There won't be any holidays like Saturday and Sunday also. We will be at a stretch. We will be most probably we are going to cover except this week. Okay. So from next week onwards, you won't have any weekends. Okay. Continuously every day we will have the session. Why? Because if there is a leave comes, okay, if leave comes, automatically the interest towards joining the class will be disappeared and most number of the candidates are not attending the session. So I don't want that to be happen. See, that is not because or because like this will be happen to every faculty. If there is some leave came, automatically they will say that okay, we will attend tomorrow's session. Even though we are getting the videos, so we will see the videos. Watching the videos, I won't say that that is a great thing. Okay, why? Because see, live classes are happening and the faculty is in front of you and he is saying you the live session. If you attend the session, then if there is any doubts, I can clear you out. But if you watch the videos, you will watch the videos. Okay, some points you won't understand, and then you will attend the next session. The next session will be way too forward, and at that point, when you ask the question, so it will be irrelevant. So your question will be there itself, and you will be having the doubts. But the faculty is going on to the next concept. So my recommended thing is please attend the sessions. Okay, before you go and say that okay, I have why we are providing the videos in the sense for your reference for the practice. Videos are not everything. Videos are provided because of references for your practice. That's it. Apart from that, I will watch the videos. I will learn the concept. It's your choice. I'm not going to say that you cannot learn from the videos, but videos are provided as a reference point for your practice. Don't take them as an main what I can say main subject for your entire course. Okay, videos will be provided, documents will be provided, and everything will be provided to back you up on your skills. Okay. Questions. Questions. Okay. So, if no questions, I'm going to wind up the session here and we'll meet in the next session and discuss more and more about the containerized application. So, what is meant by so I don't think another session is needed. Directly, we can jump on to the Monday's session. Okay. So, if anybody, why? Because Monday we will be integrating both the batches so that I have to start the C groups. I will discuss with the DURGASOFT. If there is a possibility, I will directly take from Monday itself. What's your opinion on this? Do you need another demo or else can I go directly on Monday? Guys, are you there?
Yeah, Miss. Yeah, today is my first. So yeah, Miss. I'm comfortable with Monday also.
Okay. Anybody who are attending for the first session, if you think today is the first session, previously what is the concept that we have covered? We didn't cover anything. We have just started the session and we just went for the syllabus part. That's it. I am not got into very in-depth analysis of the content. Okay, so today is the first session where I have totally discussed about the technical part. Okay, don't worry, whoever has attended today, did I miss anything else? So you didn't miss anything. So this is the first session. We take consider this is as a first technical session. Okay, so yeah, most probably tomorrow you will have the session. We'll discuss anything. Just like half an hour to 45 minutes. We will discuss about something different and then we will go back on Monday. From Monday, you will have the main concept. So have a nice day and bye bye.